we are going to look at how to find d2y dx squared. We know that if x is and y are given in parametric equations, to find dy dx, you'll find dy dt, so you find dy dt, you find dx dt, right? Since you are given x in terms of t, y in terms of t, you find dy dt, dx dt, then you divide, you get dy dx. So my question here is, to find d2y dx squared, can you do this? Can you find d2y dt squared? Then you find d2x dt squared. Then you say d2y dx squared is d2y dt squared times dt squared over d2x squared. Then it's like this cancel. So it's d2y dx squared. Now what you have in chain rule, you cancel dt squared and dt squared. It turns out that this is wrong. And to find d2y dx squared in parametric differentiation, to find d2y dx squared, you need chain rule. You know chain rule tells you dy dx is dy du n times du dx. Right? When it's first derivative, you can take it as du and du cancel in some sense, but not for the second derivative. So that means you can take it as d dx of y. dy dx is same as dy dx is same as d dx of y. Then it's same as d dx of u if you write dy du. So that means d dx of y is d du of y times du dx. So you must make sure these two are the same. It means you can write it as dy dx, or you can write it as, let me rewrite, or you can write it as like this. You can write it as d dx of y. You can use any variable. Originally you wanted to differentiate with respect to x. Then you can write it as d dt of y, then dt dx. This one also can. As long as the variable is the same, then you'll be okay. You must make sure dt, and here dt. And I like to use box, so let me change it to box. If you change it to box, means d dx of box equal to d dt of box, then dt dx. You can fill in any expression in the box, but you must fill in the same thing. And you can use this to find d2y dx squared in parametric equations differentiation. And this is how you should be doing. So I just mentioned is like this. To find d dx of box is same as d dt of box, then dt dx. And you can fill in dy dx. You can fill in dy dx here. So let me show you what to do. To find d2y dx squared. To find d2y dx squared means you want to find d2y dx squared. Means you differentiate dy dx one more time. Means d dx of dy dx. You differentiate dy dx one more time. So that's why d2y dx squared is same as d dx of dy dx. So that means dy dx will go inside the box. So that means you can fill in, if you fill in dy dx, so if you fill in dy dx, then it will be d dx of dy dx. And it's exactly this step, d dx of dy dx. Then it will be ddt of dy dx, ddt of dy dx, and dt dx, and then you get this. So you just fill in dy dx into the box first. Okay, yeah? And which means to find d2y dx squared, the correct way to do is to find ddt of dy dx, find ddt of dy dx, and then multiply by dt dx. So it means you do ddt of dy dx, then multiply by dt dx. And then you'll find it makes sense. If you interpret it, it tells you to find d2y dx squared, you differentiate dy dx with respect to t, then multiply by dt dx. Then it makes sense because if you look back to the example we have here, dy dx is actually cotangent TO2. dy dx is cotangent TO2 because you are given x in terms of t. So dx dt is in terms of t, dy dt is in terms of t. So dy dx is in terms of t is cotangent t over 2. Cotangent t over 2. So which means in the example we have, dy dx is cotangent t over 2. So which means it tells you to find d2y dx squared in parametric equations, you do ddt, you differentiate dy dx, which is cotangent TO2, and this can be done. You'll find if asked to differentiate with respect to x, you can. To find d2y dx squared means you differentiate dy dx one more time. If you try to differentiate directly, you can't because dy dx is in terms of t. So if you do ddt of dy dx, you differentiate cotangent t over 2 in terms with respect to t, which is all okay. Yeah? Then you multiply by dt dx, and dt dx is what we have found earlier. So it's actually this one. dt dx is a 1 minus cosine t, a 1 minus cosine t. So you just sub in. So this is dt dx. What is dx dt is a1 minus cosine t. Yeah? So which means dt dx is actually 1 over dx dt. Yeah? 1 over dx dt. 1 over dx dt. It's 1 over dx dt, so it should be 1 over a bracket 1 minus cosine t. Yeah? And that will be the answer final. That means you differentiate this, work out this answer, then multiply by 1 over a 1 minus cosine t. Yeah? We'll be looking at this in the later slide. Let me erase this first. I want to write down include the dt dx equal to 1 over dx dt into the formula here. So which means you can take this as a formula. You can take this as a formula. You can take this as a formula. You can take this as a formula to find d2y dx squared in parametric differentiation. You find ddt of dy dx times dt dx, or you can also find this one, ddt of dy dx. It means you work out this, and then you multiply by 1 over dx dt. You can also do it this way. That means you work out ddt of dy dx, and then you multiply by 1 over dx dt. You can also take this as a formula. You can take this one or the last one which I have just written. Okay? Because dt dx is 1 over dx dt. This is a known result. dt dx is 1 over dx dt. So instead of writing dt dx, you write 1 over dx dt. And the reason why I want to write it this way is because in a given parametric equation, you are given x in terms of t. Like the question is actually x is actually a t minus cosine t. Yeah? So you actually work out dx dt directly. So you know dx dt. So to have dt dx, of course, it will be 1 over the answer to dx dt, which is a bracket 1. Here should be sin t. You can look back to the question. It should be sin t. It's t minus sin t. So it's t minus sin t. Yeah? So it's t minus sin t.
And with that, you can actually have, so can use either one. So you can use either one.